Right now, if you are standing near the equator, you are hurtling through space at roughly 1,000 miles per hour. You don't feel this blistering speed because of inertia. Think of riding in a commercial jet cruising at 500 miles an hour. As long as the velocity remains constant, you can pour a cup of coffee without spilling a drop. You, the plane, and the coffee are all moving together. But imagine what happens if that jet instantly slams on the brakes. Now apply that to the entire planet. What happens if the bedrock of the Earth suddenly stops rotating entirely? Surviving the abrupt halt itself is only the beginning. Remaining on the surface of a stationary world is the ultimate worst-case scenario. There is a popular myth that if the Earth stopped on a dime, the sheer momentum would launch humanity straight into orbit. To actually break free of Earth's gravitational pull, you must reach escape velocity, which is roughly 25,000 miles per hour straight up. Our rotational speed of 1,000 miles per hour doesn't come close to breaking that gravity well. Because the Earth's spin is lateral, your momentum wouldn't push you up, it pushes you sideways. Instead of floating away as astronauts, humanity, buildings, cars, and trees would instantly become supersonic projectiles, tearing across the landscape at the speed of a bullet. When the bedrock halts, the atmosphere keeps going. The air surrounding the planet retains its momentum, instantly generating an eastward-moving supersonic global windstorm. These gusts operate at over 1,000 miles per hour, more than 3 times stronger than the most violent hurricanes ever recorded. They would scour the crust, cleanly shearing off vegetation and human infrastructure, wiping away anything not fused deeply into the bedrock. The air isn't the only fluid wrapping the planet. The world's oceans also carry that exact same eastward momentum. The instant the land stops, the water keeps rushing forward. The resulting force would thrust walls of ocean miles inland, creating sheer mega tsunamis that violently slosh across the newly stationary continents. Within the first minute, the combined forces of supersonic atmospheric shockwaves and continent-drowning tsunamis would wipe the equatorial and mid-latitude surfaces completely clean of life. This 3D plot shows how rotational velocity drops based on latitude. Because the Earth is a sphere, the speed decreases the further you travel away from the equator. That 1,000 mile per hour spin tapers down incrementally as you move north or south. At the exact geographical coordinates of the North and South poles, the rotational speed drops to practically zero. A sudden planetary stop here wouldn't trigger a supersonic windstorm. It would barely register as a minor jolt. The scientists currently working at the Amundsen-Scott South Pole Station in Antarctica would find themselves standing in the only physically safe zone on the planet, making them the sole survivors of the initial inertia. Yet, surviving the first minute means they inherit a planet whose basic geography is about to permanently rewrite itself. Centrifugal force pushes spinning oceans into an 8-kilometer-high equatorial bulge. Without spin, gravity takes full control. The water drains to the poles, submerging northern plains and Antarctica, exposing the seafloor to form a continuous, dry equatorial megacontinent. If you were standing on this massive new continent, you would actually feel slightly heavier. Without the outward push of the Earth's spin working against gravity, you experience the full, unabated pull of the planet's mass. The layout of our continents and the coastlines we've mapped for centuries are temporary illusions, maintained by the constant motion of the planet's spin. With the rotation halted, the cosmic calendar breaks down. A single Earth day would now last an entire year, blocking half the globe in 6 continuous months of scorching sunlight, while the other freezes in perpetual darkness. Deep underground, the internal engine also dies. The Earth's rotation keeps the liquid metal in our outer core churning, generating our magnetic field. Without that spin, the core stops flowing, and our protective magnetic shield slowly sputters out and collapses. Without that shield, deadly solar radiation directly bombards the surface, breaking apart the atmosphere and stripping away whatever gases remain. We can look to our cosmic neighbor to see the endgame of this process. Billions of years ago, Mars likely lost its magnetic field, allowing the sun to scour away its atmosphere and turn it into a barren, uninhabitable wasteland. Earth's rotation acts as an invisible architect. It holds our oceans in place, shapes our continents,
and generates the shield that makes this planet a living world.